Thank you so much for clicking on this video. This one's about Leclanche Cell, i.e. a primary battery. Before we go into that, we talk about what actually batteries are. A battery is simply any one or more cell that is connected in series, and any battery or cell that we use as a source of electrical energy is basically just a galvanic cell where the chemical energy is converted to the electrical energy. This chemical energy comes from the redox reaction that takes place in the galvanic cell. So that's what is a battery. But for a battery to be of practical use, it should be reasonably light, compact, and with a constant voltage, i.e. the voltage shouldn't vary or fluctuate during its use. There are obviously mainly two types of batteries. You have primary and secondary. In the primary batteries section, the NCERT discusses two more types, the Leclanche cell and the mercury cell, which we'll talk about in a different video. So talking about primary batteries, in these batteries the reaction occurs only once, and after the use over a period of time the battery dies and it cannot be reused. So this reaction occurs until the reactants are there in the cell. Once the reactants run out, the reaction stops and the battery dies and it cannot be reused. So the most familiar example of a primary battery is obviously Leclanche cell, named after its discoverer, used in transistors and clocks. This is how it basically looks. You have a carbon rod, or you could call it a graphite rod, and that acts as a cathode. But in reality, if you see in the cathodic reaction, there's no involvement of graphite at all. What is involved is from the paste that surrounds the cathode. So if you see the region shaded in purple, the paste is of MnO2 and carbon black. And then between the electrodes, as given in here, between the electrodes you have another moist paste that is of NH4Cl and ZnCl2 shaded in blue here. So the NH4 plus from here and MnO2 from here are what take part in the cathodic reaction. So we'll quickly do the electrode reactions in the Leclanche cell. I have to tell you about this, that anode is this. The zinc cup that everything is inside of is actually what acts as the anode. So at the anode, the zinc gives up 2 electrons and forms zinc 2 plus, and at the cathode, as I said, the MnO2 and the NH4 plus react to give MnOH and NH3. MnOH looks like this. So the oxidation state of manganese in this is only +3, whereas here it was +4. So obviously manganese is being reduced in this reaction. That is the point given in the NCERT. Next, coming to ammonia, it goes and it reacts with the zinc 2 plus that comes from the anode, and they form a complex ion, which is tetraamino zinc 2 ion. The formula is as this, given in the NCERT here. The last point about Leclanche cell is that it has a potential of nearly 1.5 volts, and it's better to remember it because the numbers are slightly different when it comes to Leclanche cell and mercury cell. So if you remember it, it's better. That's all for this video. Thanks for watching.